Okay, it's 4.6 Trig Identities, a very scary section, a section that will take a very long time to understand, but a section that will also have have a lot of fun with math because it's kind of like puzzle solving. So if you like puzzles, you're in for a nice treat. If you don't, this is going to be treacherous. So, what is an identity? So an identity it's kind of like an equation, so let's just define it here. An equation that's true no matter the value of the variable. So for instance, an equation that's true no matter what variable, I'll make a very simple example. X plus x equals 2x. So this is an identity because no matter what the value of x is, this is going to be true guaranteed. 1,000,000 plus 1,000,000 equals 2,000,000. 1 plus 1 equals 2 times 1. This is true no matter what. There are obviously some equations where there's only one solution for the value of x. So this is an easy way to understand an identity. It might not be really 100% accurate in terms of what we're getting into, but I like to relate it to equations because it's pretty much the same except completely different. Okay, so the identities that you're going to have to know, and you still don't really know what an identity is, but I'm going to list some identities, and then playing with them is going to be the number one struggle with trig identities. So for instance, I'm not going to prove how we get the Pythagorean identity, but I'm going to give you the first identity, and that's sine squared theta plus cos squared theta equals 1. This is an identity that is true forever. Okay, if you think of the right angle triangle, the vertical distance and the horizontal distance, and it's a unit circle of 1, this is just Pythagorean theorem with the hypotenuse. This is really 1 squared. Okay, the quotient identity is one of the most key ones, and this is sine theta over cos theta equals tan theta. So every time we see tan, we convert it to sine over cos because tan is a ratio of sine over cos. So this is my quotient identity. This is used very often in trig identities, and so is the Pythagorean identity. Okay, next is the reciprocal identity. So we just have to remember that cosecant of theta is 1 over sine theta. Secant theta is 1 over cos theta, and cotangent theta is 1 over tan theta. These are easy. Actually, they're all easy to remember. It's how to use them that proves to be difficult sometimes. Okay, so it's not the identities that are the difficulty, but you have to remember that you can rearrange these to form any other identity you want. So for instance, if I want to find an identity to replace sine squared theta somewhere in my equation, I can solve this identity for sine squared theta and get sine squared theta equals 1 minus cos squared theta. So I'm just bringing that cos squared over and subtracting from this side. And now if I see sine squared theta anywhere in my equation, I can replace it with this, or vice versa. I see a 1 minus cos squared theta, I can replace it with the sine squared theta. Now, why would you replace things? You're going to see in the first example that I do. The way we solve trig identities is just by replacing things until the left side equals the right side of an equation. So for instance, over here, I'm going to do x plus x, and I'm going to say 2x equals 2x. And I've proved this identity because the left side equals the right side. It looks identical to each other. Even though this is seemingly identical, you need a skill to understand that this is identical. You need a skill of addition to understand that. So we're going to take it up like 406 notches and say, I need the skills of trigonometry and their identities in order to solve, not only solve equations, but prove identities. Okay, so these blue identities are musts. And even, for instance, if I have a tan squared theta, this is the same as sine squared theta over cos squared theta. Okay, so all these things can be changed into an infinite number of different identities. And the more versatility you have with changing these into looking like something else, the easier the process is going to be of working through identities. Okay, so I've listed some general steps to follow. Now, there's not really a concrete set of steps that we follow for trig identities because one person can do it in 6 steps, one person can do it in 2. Another guy's going to do it in 16 steps. So it's really, the world is your oyster, and the more skills you have and the more versatility you have with your math, the easier this is going to be. So some general steps to follow. We always want to start with the more complicated side first. So there's two sides to an identity. We analyze to see which one is more complicated, and that's the side we want to start with. Next is pretty easy. We want to change everything that isn't sine and cos into sine and cos. So every reciprocal identity, we flip and we come up with sine and cos. All tan thetas, we change into sine over cos. We want everything in sine and cos. Not necessary, but we like it. 3, always check for Pythagorean identity. It's always something that we miss. So please make it a rule. Every single time you see some squares somewhere, we look for Pythagorean identity. Now, number 4 is the most important one. We've got to use your skills. And these skills in math are very, very simple skills, but seem challenging because of all these letters and symbols we have, such as sine, cos, and tan. So the first skill we're going to use is, if we see some fractions, we want to add and subtract them. Fractions. And we do this by finding the common denominator. Now, this is going to be more challenging than you're probably used to, but it is the same as chapter 2, where we have to find common denominators with binomials or trinomials, whatever the case may be. It'll involve factoring, all that beautiful stuff. The second step, which is a new step, we're going to multiply by the conjugate. You have no idea what this means, and I'm going to explain it when we get into an example that this is required. Number 3, factoring. Now, these are not steps that we do every single time. We don't always multiply by the conjugate. We don't always add or subtract fractions. I do this if I have to. If I have nothing else to do, I add or subtract the fraction. If there's nothing else I can do, I multiply by the conjugate. Factoring is probably going to happen every single question, give or take, especially for the more difficult questions. So these are not things that we do in order. These 4 steps are general things that we like to follow, and these are just me listing some skills that we're going to have to experience pretty much every single question. Okay, so I'm going to put up the question, and we are going to use these steps to make our way through this problem and prove an identity. Okay, so our first identity is tan squared theta plus 1 equals secant squared theta. Now these thetas can be x's, they can be a's, they can be b's. They're generally capital letters. This is actually the Greek capital letter T, theta. So it doesn't matter what that symbol is. I always have a habit of doing theta, so I pretty much use theta all the time. It's just a nice flow to write the letter theta. So we're going to follow our steps. We're going to pick the more complicated side to use first. Now, if you think this is more complicated, you're incorrect. This is a binomial. There are 2 things here, so just because of that, it's more complicated. And our second step is to change everything to sine and cos. So I'm going to change this tan into sine over cos. And because it's squared, my sine and my cos are squared. Okay, I don't have to write the right side. I'm working with the left side. If you wish to work with the right side at the same time, you can. It's just frowned upon. Okay, but I mean, if you're doing a test or you have to get to the answer, work with both sides. Now, what do? I have a fraction with a 1. I use one of my math skills, right? I can add this, but this has to be in a common denominator. So I'm going to change this 1 into a common denominator with the cos squared theta. So this is sine squared theta over cos squared theta plus cos squared theta over cos squared theta. And now that they have a common denominator, I can write the numerator over 1 denominator. Okay, just combine the numerator. And now I'm going to analyze for Pythagorean identity. I could have done it early, but I didn't see anything. I mean, I saw the sine squared theta plus 1 over here, and that was kind of piquing my interest. But now that I collected the common denominator, I see for sure that this up here, this is just Pythagorean identity. So I'm converting that to a 1. And this is 1 over cos squared theta. Actually, I'm going to erase that because I don't like changing one side if I don't have to. I'm going to go over here, and I'm going to go 1 over cos squared theta is secant, and this equals the right side. Therefore, the identity is true. Okay, so here we have a bit of a more complicated example because we have fractions on both sides and we have a binomial in each one of those fractions. So which side is more complicated? So I'm going to tell you which side is more complicated with my reasoning. So if you encounter something like this, you will know. The right side is more complicated. Why? Because the binomial is in the denominator. When stuff is complicated at the bottom of a fraction, it is way harder than if it's complicated at the top of the fraction. Okay, so when you're looking for complications, we look for those complicated denominators in fractions. Now, this is going to be the first time you see multiplying by the conjugate, and I'm going to tell you what to do. When you have something complicated at the bottom, there's nothing I can change 1 plus cos theta into that helps me with my identities. Okay, so I use a process called multiplying by the conjugate, and this is what this is. So I rewrite the fraction, and I multiply it by something that is the value of 1 that doesn't change this fraction, but it is the opposite of the denominator. So all I have to do is rewrite the denominator, but change the sign. 1 minus cos theta over 1 minus cos theta. So it's the exact same as the denominator, except it's over itself and it's subtraction. Now, why do we do this? We do this because the denominators multiplying by each other here are something that we're interested in, and we've learned, is this difference of squares. And difference of squares helps us get a square cosine. Okay, and square cosines help us with Pythagorean identity. It helps us with other things too, but we're really interested in this difference of squares. So the top's going to be pretty straightforward. Sine theta 1 minus cos theta over 1 minus cos squared theta equals. Okay, so I just use difference of squares to multiply these two things together, and I'm done over there. Okay, now next I'm looking at the bottom here, and this is part of my Pythagorean identity, right? So Pythagorean identity is sine squared theta plus cos squared theta equals 1. But if I bring that cos over, remember I told you sine squared theta is 1 minus cos squared theta. So I'm going to convert this 1 minus cos squared theta. I'm going to keep the numerator the same, and I'm going to change it to sine squared theta. Okay, I'm going to erase this side. Okay, now these signs, one of them cancels out. This is like saying x over x squared. So over here, I lose the sign on top, so I have 1 minus cos theta, and I'm left with one sign on the bottom, because one of the x's technically canceled out, x over x squared. Okay, so I'm still left with an x at the bottom. So it's hard to see initially when we're talking about sine squared and regular signs. To see that is difficult. It's probably the hardest part of 4.6. But once we get over that hump, everything will clear up. Okay, now, I'm looking at this. I look at the question. This is the right side. I'm done. Therefore, the identity is true. Okay, so for those guys who are really confused right now, what is going on? This is not a process that is the same for everyone. This is not math that you can look at this example and apply it to another example. These are just general tips to get through this to reach your destination. Your destination is the right side of the equation. So when in doubt, you have to do something. If this doesn't look like this, do something to it. Whatever it is, anything mathematically correct will work. Now, with experience, you will slowly learn what to do that will get you to your answer in the fewest number of steps with the smallest amount of error. And that's what Trig Identities is. It's you problem solving and trying to take the shortest route to the answer. This is math in general, really. That's what math teaches you. But it's going to be a struggle. Okay, it's usually a struggle at this level. Please don't discount it because it gets really nasty in grade 12. It's really important, especially if you get into engineering. Mathematical proofs are pretty prominent in first year. So please focus on it, ask questions. I'm hoping I get a lot of questions from 4.6 Trig Identities.